for my presentation, I just want to tell you a little bit about the applied research I've been doing here in the Champlain Valley over the past 2 years using the pollen tube growth model. So just a quick background on crop load management here in Northern New York. Generally during our typical petal fall and 12 millimeter thinning season, we do tend to have fairly cool sunny weather. So it can make it difficult in some years for our PGRs to really give us the amount of thinning that we might be looking for. In addition to that, in 2019 and 2021, we've had some issues with return bloom on our Honeycrisp block. So we're very interested in using different materials that we can use earlier at bloom to start that thinning process to hopefully get better return bloom. And we're also interested in just having more materials available that can complement those PGR materials that we are traditionally using at petal fall and 12 millimeter. So there has been a lot of interest in trying out some of these different materials at bloom. And to that extent, a few growers have been using ammonium thiosulfate, which is one of those caustic materials that Greg was talking about at bloom time, and have been using it on and off for a couple of years with varied success. So there was a lot of interest in using this material. So, it was really well timed that these models were becoming available to us. And again, I'll just briefly discuss the pollen tube growth model with you. Just to show, this is from a previous example where we had gone out and measured those style lengths as Greg mentioned, popped those into the model, and then counted the number of blooms that were opening up on the trees, to which point the number of flowers matched our target crop load per tree. We entered that into the model, and in this case, we got an application on at 70% of the pollen tube growth and a follow-up one at 80%. So that's, again, how you read that model. And then on top of that, there's also another model that Terrence will talk about later called the fruit growth rate model that we've also been using. And with this model, essentially, you go out and you again count the number of fruit buds that are on those trees. And then we tag off 15 clusters and measure the fruitlets after our different thinner applications. And we can actually predict how many fruit are remaining as we go through those sequential thinning applications. So for this project, what we really wanted to do was combine those two models and answer the question of how ammonium thiosulfate and lime sulfur time with the pollen tube growth model compare with our more traditional bloom thinning programs. And we wanted to see its effect on crop value in that year, and then also how well it promoted return bloom in the following season. So I'll show you our trial setups, and there's a lot here, but the basics I want to show you is that in our 2020 Gala trials, we had 2 rows of Gala on M9. These were planted back in 2012, and they were trained to a tall spindle at 4 by 12 foot spacing. And as far as the actual treatments, you'll see treatment 1 was a fairly traditional NAA at 10 parts at full bloom. And then we follow that up with a fairly traditional petal fall, 12 millimeter and 18 millimeter program based on the fruit growth rate model outputs. In contrast with that, we had our experimental treatment. This was that ammonium thiosulfate, and we applied that at 60% pollen tube growth model growth. And that went on twice. So that first time at 60%, and then a follow-up application when it hit 60% again. And then those trees were followed with that same follow-up applications at petal fall 12 millimeter and 18 millimeter. This is our 2021 Gala trial, and very similar, same block as 2020, and very similar setup as far as our treatments. Again, that NAA at full bloom, and our treatment 2 was, again, ATS at 60%. The only difference in this case was that we actually did 3 applications of the ATS. And the reasoning for that was we had a lot of lateral blooms that were opening up on 1-year-old axillary buds. So we wanted to make sure we were hitting those. And then we had a couple of small changes to our follow-up applications. Now I'll switch over to our Honeycrisp trials. Looking at 2020, we had 2 rows of Honeycrisp on M9. This was a younger block. It was planted in 2015 and was trained to a vertical axe at a 6 by 14 foot spacing. And again, you can see our first treatment was a traditional NAA at full bloom. And our other treatment was ATS. And this one actually went on a bit earlier at 20% pollen tube growth model development. So for this trial, we only did one application. And then these were both followed up with a petal fall treatment. And then finally, our final setup was our 2021 Honeycrisp trial. These were 2 rows of Honeycrisp again on M9. This was trained to tall spindle, 3 by 14 foot spacing, planted in 2012. And now we had that NAA treatment. We had a ATS treatment, 2 applications at 60%. And then we had a third treatment this year, and this was lime sulfur and oil. And this went on at 100% pollen tube growth for that first application. And then for the follow-up application, we put it on at 60% pollen tube growth. And then again, we had follow-up applications based on the fruit growth rate model at petal fall, 12 millimeter and 18 millimeter. So we did use the fruit growth rate model as well as the pollen tube growth model. And again, for this model, we tagged 15 clusters on 5 of the ATS treated trees at pink. And then we counted the number of fruit clusters per tree to tell us what our starting bud count was. And again, we were excluding 1-year-old axillary buds when we were counting those clusters. And then following our petal fall application and each subsequent application, we went out and measured the fruitlets of those tagged clusters. And we did that at 50 and 120 degree days base 4 following those applications. Now I do want to quickly tell you about the harvest evaluations that we did. So at harvest, we went out and recorded the number of fruit per tree and the weight of the fruit coming off of each tree. We also calculated fruit size, and we also have data on fruit quality, including size and color. And in 2021, we also evaluated fruit russeting in our Honeycrisp and Gala trials. And then we also did return bloom measurements the following spring. Of course, we don't have the 2021 return bloom yet. We'll be getting that in a few weeks. So looking at some of our results, I did want to briefly touch on the fruit growth rate model. You can see this from 3 of our sites. Starting with the 2021 Gala model, our target crop load per tree was 100 in fruit. And we actually calculated that our initial fruit on the tree was about 1,225. So certainly a lot of thinning to be done. Following that post petal fall application, the model was predicting that we had 723 left. So that tells us that thinning with ATS alone was not doing the full thinning job that we needed. So we put on those additional applications. And by the end of thinning, the model was predicting that we had about 74 fruit per tree. And at harvest, we actually had about 167 fruit per tree. We saw fairly similar in 2021 on Gala. Our target again was 100. We started around 1,200. Post petal fall, we were down to 527. And then it was predicting 94 at the end of our thinning, and we actually had 168 fruit per tree. And then looking at our 2021 Honeycrisp, we were targeting 85. Our initial fruit was at 1817. Following our bloom thinners, we were at about 1,000. And then finally, following all of our thinner applications, it was predicting we were at 91. And we actually picked about 108 off of each tree, so we were fairly close on that one. But Terrence will talk more about the fruit growth rate model shortly. So now I want to show you our harvest results for our Gala trials. So when we look at our 2020 results, again, just pointing out that our target crop load per tree was 100 fruit. And you can see the number of fruit from both of those different bloom treatments. Generally, we did not quite reach our target. And in fact, we saw very few differences in terms of the number of fruit per tree. We also did not see differences in terms of the yield per tree, or the fruit size, or the fruit color. And we also did not see a noticeable difference in crop value nor return bloom. So overall, we had very similar results between both of those bloom thinning treatments, between that traditional NAA and the ATS with the pollen tube growth model. So we're getting similar results out of it. And we saw very similar results this past year in 2021. So again, targeting 100 fruit per tree. Again, fairly similar numbers, 168 versus 183. And again, no significant differences in terms of yield, fruit size, fruit color, or crop value per acre between those two bloom treatments. So now we'll take a look at our Honeycrisp harvest results. So in 2020, our target crop load for those trees, because they were younger, was only 45. And we were very close to our target in both the ATS and the NAA at bloom treatments. And they did not differ statistically between those two. Nor did we see any statistical differences in terms of the yield per tree, the fruit size, fruit color, or crop value between those two. And we also did not see any differences in return bloom, and we were really disappointed. The return bloom in this block was just very, very poor this year, 5 and 2%, so very low. We do know that 2020 was a very stressful year, so we think that paired with it being a young block on a sandy soil are likely at play here. Looking at our 2021 harvest results, again, we have ATS, lime sulfur, and NAA now. Again, we did not see any statistical difference in our number of fruit per tree. And again, I'll mention our target was 85. So the lime sulfur treatment got closest at 87, followed by the NAA at 105, and then the ATS at 108. But again, statistically, there was no difference here. Nor was there any difference in terms of yield per tree or fruit size. Interestingly, we did see an increase in fruit color in both the ATS and the lime sulfur at bloom treatments. And I also want to point out, as Greg mentioned earlier, that we could have some negative impacts from using these caustic materials, and one of those being russeting of the fruit. So when we looked at our percent of russet-free fruit, the NAA treated trees nearly free of russeting. The ATS treated trees did have some russeting, about 9%. And then we actually had about 17% russeting on our lime sulfur treated fruit. And so when we look at sort of the fruit quality of fruit size and fruit color and pair that with the amount of russet-free fruit, we were able to develop a relative crop value per acre. And we found no statistical difference, but I think it is interesting to point out that our estimated crop value per acre for the ATS treated fruit came out to about 28,800, while the lime sulfur and the NAA at bloom came out to about 24,000. So not statistically different, but still, in my mind, a noticeable difference when we look at the numbers. So I do also just want to briefly show those same economics, this time added in with the cost for those materials. So this just shows the cost of the materials for all the applications along with a rough labor rate associated with them. And when we look at the crop value and the cost differences, you can see for our Gala trials, they came out to, or in 2020, excuse me, ATS in 2020 gave us better returns in our Gala and in our Honeycrisp trial. And when we look at 2021, we had a higher value from NAA in our Gala trial. But again, in our 2021 Honeycrisp trial, we did see quite a bit of a jump with the ATS treatment. So the takeaways from the past 2 years, generally, I would say bloom thinning at a 2.5% concentration timed at 60% pollen 2 growth model looks to be as effective as NAA at bloom when we combine them with additional thinners later in a combined thinning program. But I do want to just point out, think about if it's worth the extra time commitment. And it certainly may be if you are able to get better return bloom. We didn't see it in our first year, but we are hoping to see some differences there. But it certainly does take a bit more time investment to go out, measure the styles, count the blooms opening on your tree. So something to keep in mind if you're going to be doing this. Again, while not statistically significant, the Honeycrisp crop value does appear to increase with the ATS at bloom. We want to repeat this again and see if that trend continues. And again, we saw that from the increase in fruit size and color. The lime sulfur at the 100% pollen 2 growth did give comparable levels of thinning in Honeycrisp in 2021. But again, we did note that there was some rusting from the ATS and even more rusting from that lime sulfur treatment. So the crop value was improved in the lime sulfur in terms of the size and color, but that was negated by the rusting. And lime sulfur is not labeled in New York, and certainly partially for that reason. So return bloom was not improved by ATS in 2020 in either our Honeycrisp or our Gala trial. Again, we know that was a very stressful year, so I'm curious to see what we find out in the next few weeks. As far as the fruit growth rate model, it did overpredict the amount that it took off on our Gala trial, but I do think that part of that was from my own user error. So we're going to be adjusting that a bit this year. And again, there is a bit of a time commitment for doing that, but I do find it very valuable. If you do have the time, it is a really nice way to have a sense of how much thinning you've done with your previous application. So if you have that time, I do recommend using it. And Terrence will talk more about that shortly. And then when it comes to taking the pollen tube growth model and really scaling it up for commercial use here in the Champlain Valley, we did find that there are just logistical challenges. In a year where you have a prolonged bloom like we did in 2021, trees were opening up very slowly. So when exactly do you start the model was a difficult question for us. In addition, one of the blocks we were working was very close to the lake. So trees that were closer to the lake, getting that cooler air, were opening up much more slowly than trees just a few hundred feet away. So being able to account for that is a big management question that we want to keep working with to address. And then certainly on farms with multiple blocks of different varieties and rootstocks and different ages, again, those flowers are opening up at different times. So certainly more work to be done to figure out how to best scale this up to a commercial operation. So moving forward, we are planning to repeat this study for a final year, and we're going to include lime sulfur in our Gala trial next year. And we're also planning to add a 3.5% ammonium thiosulfate treatment to see if we can reduce the amount of follow-up PGR applications that we need to make. So with that, I'd like to thank you for listening to my talk. I'd like to thank the Northern New York Agricultural Development Program for funding this project. And I'd like to thank Dr. Robinson and Peck, my technician, Andy Gallimberti, and Northern and Florence Orchards for helping out with this project. So thank you.